Good morning, everyone. Today we will see graph algorithms. Breadth first search. First, we will see what is graph. Graph is a mathematical structure to represent the objects and relationship between the objects. It consists of vertices and edges. Vertices are always called as node. Edges called as link. Vertices represents the object or the point in a graph. Edges, it connects two objects or two points or two vertices. That is called edges. See the diagram. There are two examples. First one, there are four vertices or four nodes called A, B, C, D. Each node labeled with some numbers or alphabets. So A, B, C, D are vertices. And the line, the edge connecting two nodes is called edges. This is a connection between two vertices. Here in this diagram, AB is a edge, BD is a edge, DC is a edge, and AC is a edge. There are four edges and four vertices in the first graph. See the second graph, there are five vertices, A, B, C, D, E. And what are the edges? AD, DC, AC, CB, CE, and BE. These are the edges. So this is a basic terminology in graph, vertices and edges. And we will see what is graph traversal. Graph traversal is a process of visiting all the nodes exactly once. This is called graph traversal or search. Starting at a one point, we visit all the vertices only once. That is called graph traversal. It is a fundamental concept in graph theory, used in various algorithms to explore the structure of graph and solve problems. And the systematic explore the graph, ensuring no vertex is missed. So, exploring all the vertices in the graph is called graph traversal or graph search. This exploration can be done in different orders, leading to different various algorithms. There are two types of algorithm, breadth first search and depth first search. So, how in which order we are visiting the node, that gives the different versions of searching algorithm. Algorithms classified based on the order of nodes visited. And we will see why graph traversal is important. Because there are graph is a network or structure where we can store the data. If we want to search for a particular node, we have to traverse it and we have to find a path or cycles, some directing or removing some elements from the graph and solving puzzles and mazes and network problems. Normally, computer networks systems are connected in a network that is represented in the form of graph. And first we'll see breadth first search algorithm. This is otherwise called as level order traversal. We are traversing or we are visiting the node level by level. Traversal means visiting all the nodes without revisiting or without missing any vertex in the graph. Visits all the neighbors of a node level by level. First, take one node, visit all its neighbors, that is one level. Next, visit another node's neighbor. So, that is a level by level search is called breadth first. It uses the concept called first in, first out based on the data structures called queue. Queue is implemented uh, for breadth first search algorithm. It is suitable for finding shortest path in an unweighted graph. It's mainly used for used in unweighted graph to find the shortest path. See the example. This is a tree. How we are going to apply breadth first search in a tree. First, starting node is A. So normally we will start at node with minimum alphabet or minimum numerical. Here A is a minimum. So we start at node A. Then find A's all adjacent nodes. Find adjacent node of A. So there are three adjacent nodes B, C, D. So visit all nodes in alphabetical order. B, C, D is visited. See the PFS path. First initially A is visited. Then adjacent node of A, B, C, D is visited. Now this level is over. Go to the next level. Next level, the previous level, first visited node is B. So visit the adjacent node of B, that is E and F. Next. Now, what are the second node visited in the previous level? Node C. Visit the adjacent node of C, G and H. And third node, the second level, D. Find the adjacent node of D, I and H. So visit the node I and H. So this is called breadth first search, level by level. First level node A, second level B, C, D, third level E, F, G, H, I, J. So for implementing these type of algorithm, first in first out queue data structure is used. This is always called as level by level traversal. And we will see how to apply breadth first search in a graph. So given undirected graph G, there are 5 nodes A, B, C, D, E and write adjacency nodes. Adjacency node means it's a neighboring node. I'll list out all 5 nodes A to E. First find out the adjacent node for A. Adjacent node means there's a neighbor node. For adjacent node A is B and C. For adjacent nodes, there are 3 outgoing edges. So 3 adjacent nodes. So write in alphabetical order. So for B, A, C, D are adjacent nodes. So write in alphabetical order in the adjacency list. Then for C, 3 outgoing edges. Or 3 edges are connected with C. So find out the nodes and write in alphabetical order. A, B, E. For C is A, B, E. For D, only 2 edges B and E. And for E, C and D. So now the first step is develop a adjacency list for each node in a graph. Then step 2, how to traverse. Traverse means how to visit the node. So first we are using the data structure called queue. We are using one more array, visited array. So there are 5 nodes. Initially all node values are 0. That means all nodes are unvisited. Initially, the node values are 0. 0 means the node is unvisited, not yet to be visited. 1 means the node is visited. So the array value, the node value is 1 means visited, 0 means not visited. See the queue structure. Initially, A is visited. Initially, the step 1, visit the node A. So after visiting the node A, put A in the queue and change the value of A to 1 in a visited array. That means A is visited. 1 means A is visited. This is the first step. Starting at A, put A in a queue, then change the value of A to visited. And next step, what is the element in Q? A. Now find the adjacency node of A. See the adjacency list. What are the adjacency node for A? B and C. So push the element B and C in a queue. B and C. And visit the node. Push means that is visit. Visit the node of adjacency node of A. That is B and C is visited. B and C is visited. So change the array value to 1. B and C array value will become 1. Now the second step is over. A is visited. Adjacency node of A. B and C is visited. Then now why we remove A means all adjacency node of A is visited. Yes, B and C is visited. Now remove the element from the queue. First in, first out. So remove the element A from the queue because all adjacent nodes of A is visited. That is, adjacent node of A is B and C. B and C is visited. The value is changed to 1. Then remove A. Now, What is the element in Q for visiting? Take the node B. First in, first out. A is removed, popped out. Now there is a first added amount element is B. Now take B. Find the adjacency node of B. B adjacency node is, check the adjacency list. Adjacency node of B is ACD. ACD. So A is already visited. Already the value is 1. Omit the node A. And C. Adjacency node of B is C. C, visit the node. Already now visit the node C and visit the node C and next node D. Adjacency node of B is D. So now this is the second step. Visit the adjacency node of A, that is B and C. Change the value to 1. So add the path. First we visited A. After A, B and C is visited. Now see the example. Step 3. Now take the node B. Adjacency node of B is ACD. A is already visited. Then visit C and D. So change the value of C and D to 1. So visit the node C and D, then add the node in a PFS path, C and D. So C and D is added. Now, after adding all the adjacency node of B, remove B from the queue. So C and D. This is the third step. So change the color. C and D is already visited. And now take the node C. So already AB is removed from the queue. Next, C is ready for pop. So take the node C. Visit the adjacency node of C. What is the adjacency node for C? ABE. So AB is already visited. The value is 1. Now visit the node E. Add the node E in the queue and change the array value of E to 1. That means it's visited. See the graph, the color is changed. Now all 5 nodes are visited. Now still we have 2 more elements in the queue, D and E. And step 5. And take the element D. From the queue, pop the element D. See the adjacency node of D, B and E. So B and E is already visited. So remove D. And then E. What is the adjacency node for E? C and D. C and D is already visited. Now the queue becomes empty. After visiting all the nodes, queue will become empty. And see the visited array, all values are changed to 1. That means all nodes are visited. See the PFS path. See, all the nodes are added only once. A, B, C, D, E. So this is the example for breadth first search. Visit the node, add the adjacency node in the queue and change the value of visitor node to 1 from 0. Then pop the element from the queue, then take next element in the queue, then visit the adjacency node of that current node. If it is already visited, no need to visit again. Just you can omit. If it is unvisited, we can visit the node. And this is a basic concept. So this process is repeated for all the nodes till queue becomes empty and all nodes are visited or added in the BFS path. This is called BFS search algorithm for graph. Then what is depth first search? So explore the elements in depth wise. For example, take A. A is visited. What's first adjacent of A? B. Only visit first adjacent for all the nodes. So first adjacent of A is B. Then for B, visit the first adjacent E. So A, B, E. Now there is no neighbor unvisited node for E. So move back to the previous node B. Find another unvisited node, that is F. F, now after A, B, E, F is visited. Now there is no more to explore from E and move back to the node B. No more, no node for exploration. They again move back to A. Then visit the second neighbor node, that is called C. From the C, visit G. From the G, there is no more node. Go back to C, then visit H. Then from H, there is no more no, there is no node, no neighbor node. So move back to C, then move back to A, then visit another option, another node, that is D. Then for D, visit leftmost node, that is I. Again move back to previous D, then visit J. So after this, all nodes are visited. This is called depth first search, depth wise. A, B, E, F, C, G, H, and D, I, H. This is the order of visitor node in depth first search. This is called DFS path. So see the path, all nodes should be visited only once. You should not miss any element as unvisited. What are the applications of graph traversal? This is mainly used in web crawling, moving from one page to another page or any page to any page. There's a link how the control is moving from one page to another page in web crawling. And social network analysis. There's some products are recommended based on the history. So all applications are interlinked. So that is used for social network analysis and GPS route finding. Find the route from one node to another node using this approach. Then cycle detection. So we are generating BFS tree. That is, tree is open one. This does not contain any cycle. So to detect whether the graph contains cycle or not, we can use this BFS concept. And topological sorting, this one type of sorting that can be implemented with graph traversal in a graph. And what's time complexity of breadth first search? B is number of vertices, E is number of edges. So we have used adjacency matrix, that is two-dimensional matrix of size B into V, number of vertices, two-dimensional matrix. And we can use two-dimensional array also, two-dimensional list, adjacency list. So time complexity using adjacency list is order of V plus E. That is number of vertices plus number of edges. That decides the time complexity. For adjacency list, T of n is equal to order of V plus order of E. And for adjacency matrix, for every vertex, the total operations V into V. That is T of n is equal to order of V square. For adjacency list, order of V plus E. For adjacency matrix, so there are V cross V matrix. V for every operations, it performs C into V multiplications. So using adjacency matrix, when the graph is dense, many edges. So when we can go for BF's implementation using adjacency matrix, if the graph has more number of edges, that is called a dense graph, we can use BFS and use adjacency list for sparse graphs. That is, graph with only fewer edges is more efficient. So, matrix for complex graph and adjacency list for normal graph with lesser number of edges. So, the time complexity is order of V plus E and time complexity is order of V square. Then what's the difference between BFS and DFS? Traversal order. So BFS is level by level order. First, take one node, all neighbors of the current node is visited. Then we will go to the next level. And DFS, depth wise. So first we are visiting the first adjacent of the node. Then first adjacent, the deep wise order. The nodes are visited. And data structures, BFS use first in, first out, Q data structures. And depth first search, it uses LIFO, last in, first out stack. And implementation, iterative using queue. This iterative looping statement. But in the case of DFS, there's a backtracking, recursive or iterative using stack. So because backtracking concept is used, so it uses recursion. So recursion, it uses the stack. Shortest path, yes. Find shortest path in unweighted graph. No, does not guarantee the shortest path in depth first search. And space complexity is order of V in worst case. And here, depth first search, order of H is height of the graph or tree. And time complexity is order of E plus E for DFS. This is for using adjacency list. Adjacency matrix means order of V square. And best use case, find shortest path level order traversal. Here, exploring entire graph, checking connectivity or cycling, we can go for DFS. Complete travel, yes, is possible. We can visit all the nodes if the graph is connected. And backtracking in BFS, there is no backtracking. This iterative approach is used. And DFS, yes, backtracking is applied because it will go in one path. It's not uh, optimal or a solution. We can move back to the previous step, find another possibilities. So this backtracking is allowed in DFS and iterative approach is allowed in BFS. Thank you.